Okay, good morning, ladies and gentlemen. This is 9th week of our academic semester, and according to syllabus of this course, today we will solve confidence intervals of confidence. We will use formulas. If you can see, you have written here only two-sided confidence intervals, yes, with lower and upper bounds. But like a supplement, I will show to you also one-sided intervals, because it's good to know. So we will start with first example. Example 9.1. When observing the lifetime of new batteries, a random sample of 30 batteries was drawn from a population of 50,000 batteries. So what it means, there is a large group, a population denoted by capital N equal to 50,000. So population of 50,000 batteries, a big group, large group, yes. And we carried out only a random sample, yes. Random sample, we selected N equal to 30, yes, 30 batteries. Using those 30 batteries, sample, yes, this small sample, 30 batteries, we calculated arithmetic mean. So, we had observations, yes, we had observations, x1, x2, x3 until x30, yes, 30 observations, and we calculated classical mean, yes, x with stripe, so this is mean calculated from the sample, equal to 195 days, yes, days. So this is mean, sample mean, calculated from the sample. 195 days. Further, the standard deviation of the battery's lifetime is known to be 20 on the basis of long-term observation. So we didn't calculate our sigma or variance. So this sigma, this standard deviation, is connected with this population, yes? So sigma is known. Sigma is known. Sigma squared is also known. So sigma is equal to 20 days. 20 days. If you calculate the second power, you have variance. 20 squared 400, yes? So sigma squared is equal to 400. So the lifetime of a battery is assumed to be a random variable which follows the normal distribution. We will construct a 95% left-sided confidence interval for the expected value of battery's lifetime. So we need to know how looks two-sided confidence interval, and we must know if sigma or sigma squared is known or unknown. Now there was written that sigma variance or standard deviation is connected with population, so variance is known. I will rewrite formula on the whiteboard. So what is written here? X with stripe, the mean, minus z1 minus alpha divided by 2, z1 minus alpha divided by 2 times sigma divided by square root from n. This is left side, left bound, and right side, right bound. X with stripe plus z1 minus alpha divided by 2 times sigma divided by square root from n. So this is two-sided, yes? This is two-sided confidence interval with lower and upper bound. Okay, the power, the strength of this interval, yes, is 1 minus alpha. 1 minus alpha is the strength of this interval. Because this is two-sided interval, you are using quantile, standard normal distribution, quantile, z1 minus alpha divided by 2. If I want construct only one-sided confidence interval, I will use only one side, but I don't have to divide this alpha by 2. I must calculate, I must construct 95% left-sided interval, so I will calculate left side. X with stripe minus z quantile, standard normal distribution, times sigma divided by square root from n. So this will be left side, and right side will be infinity days. Yes, infinity days. What is here? This is two-sided interval. I must share my power in this interval. So this is the reason why there is alpha divided by 2. But now I want to construct only one-sided. So there is 1 minus alpha. Yes. 1 minus alpha. Z 0.95. 95% quantile of the standard normal distribution. If you check the tables, if you check the statistical tables, quantiles of the standard normal distributions at p value 0.95, the value of this quantile is 1.645. 1.645. We will use this quantile and we will construct this confidence interval. So on the left side, 195 days minus 1.645 times standard deviation 20 days divided by square root from 30 batteries. So this will be the left side, yes? Right side is unknown, infinity, yes? Infinity days. So 20 divided by square root from 30 times 1.645 and 195 minus this value. So left side 188.99 days, right side infinity. So we used our power, yes, all power on the left side. So this is for illustration because you don't have this formula in your formulas, yes? It's a supplement. Now we will construct 95% two-sided interval, which is in your formulas, yes? So this formula, where is 1 minus alpha divided by 2, shared alpha, yes? My power, yes, must be shared on the left side and on the right side. So I will delete this formula in the middle and we will find the quantile, standard normal distribution quantile, 1 minus 0.05 divided by 2, 1/2 from 5% is 2.5%, 100 minus 2.5% is 97.5%, yes? 0.975. So we will find the Z 0.975, 97.5% quantile for the standard normal distribution, which is in our tables 1.96. Yes, 1.96. So this is the quantile. Yes. We are constructing 95% confidence interval, yes? 95%. According to presentation given by Mr. Hellman, the power, the strength of this interval, 1 minus alpha is equal to 0.95. Because you have here in your formulas only two-sided intervals, yes? Both-sided with lower and upper bound. This alpha is divided by 2, yes? We must share the strength. So this is the reason why there is, instead of 95%, 97.5%, yes? 97.5% quantile. So we know everything, yes? I will delete this part in the middle and we will use the values. 195 minus 1.96 times, I will use the star, yes, times 20 divided by square root from 30. Left side, yes, left bound, and 195 plus 1.96 times 20 divided by square root from 30, upper bound, right side, yes. I will delete this one-sided interval and I will calculate the result. So 20 divided by square root from 30 times 1.96, 195 minus this value, 187.84 days. And the right side, right bound, 20 divided by square root from 30 times 1.96 plus 195, 202.16 days. So this is 95% confidence interval. We calculated 95% two-sided confidence interval for the expected value of batteries lifetime. Yes, we can expect. Yes, we can expect that 95%. Yes, 95% of all batteries from this population probably, yes, will be able to work, for example, in wall watches, yes, wall clocks, at least 187.84 days, and at most 202.16 days, yes, 95% confidence interval, two-sided confidence interval. We will continue, we'll construct a 95% two-sided confidence interval, what it means, lower bound and upper bound, for the expected value of batteries lifetime in the population. Standard deviation wasn't known. It means, using the standard deviation calculated from the random sample, its value being 30. We calculated this standard deviation, yes, from this sample. So, can you see these values? x1, x2, x3, until x30. We calculated the mean, yes, we calculated the sample mean 195 days, yes, and we calculated our standard deviation. If you check your formulas, there is written that sigma squared unknown, this sigma squared, yes, which was connected with the population, with all batteries, yes, all batteries in the world, 50,000 batteries, is unknown, yes. We calculated our own sample standard deviation, which is denoted as according to this sample, 30 batteries, yes, and its value is 30. 30 days. Yes? So we calculated our own standard deviation. So we will check our formulas and we will rewrite on the whiteboard this formula using student t quantiles instead of standard normal distribution quantiles. We will use student t quantiles. So on the left side, left bound, x with stripe minus t 1 minus alpha divided by 2 times standard deviation divided by square root from n. Right side, x with stripe plus t 1 minus alpha divided by 2 times standard deviation divided by square root from n. Okay, so left side, right side, we know that we must construct 95% two-sided confidence interval. So the power, the strength of this interval is 1 minus alpha. This must be equal to 0.95. Why? Because we are statisticians. We are using relative number, yes, not percentage. So 0.95. Because this is two-sided interval, there is alpha divided by 2, yes? 1 minus alpha divided by 2, there is 1 minus alpha divided by 2. We know that student t distribution using degrees of freedom, yes? Parameter, small Greek letter mi, degrees of freedom is equal to n minus 1. In our situation, 30 batteries minus 1 is equal to 29. 29 degrees of freedom. So we will check our tables and we will find t 0.975, 97.5% quantile of the student t distribution with 29 degrees of freedom. And in tables, we'll find a table for student t distribution. Student t distribution, table 6. Yes, quantiles of the students distribution TP, p-value 0.975 in the middle, and we are searching for 29 degrees of freedom. 2.045. 2.045. Yes, quantile. So we will use this formula. The mean 195 days minus 2.045 times 30 divided by square root from 30. This is left side. Right side. 195 plus 2.045 times 30 divided by square root from 30. Okay, we will solve this. 30 divided by square root from 30 times 2.045. 195 minus this value. So on the left side, 183.799. 799. Right side, right bound. 30 divided by square root from 30 times 2.045 plus 195. 206.2 days. Yes. So result is in days. So 95% two-sided, both-sided confidence interval with unknown, yes, for unknown variance of the population. So we can expect, yes, we can expect with 95% probability, yes, 95% probability that the battery will be able to work, for example, in the wall watches, wall clock, yes, at least 183.8 days, and at most, yes, 200 6.2 days, yes? With 95% probability, we can expect this, yes? It's based on our data set, it's based on our sample, because we have here only 30 batteries, yes? Not 50,000, yes? This is our sample, so on the basis of our sample, yes, with 95% probability, we can expect this. That the battery will be able to work at least this value, this number of days, and at most this value, yes, this number of days. How would the confidence interval change, differ, if all the calculations were carried out on the basis of random sample of 100 batteries instead of 30? 100 batteries. I will use, for example, the previous confidence interval for known variance. Yes. Can you see? There was value. Wait a second. I will write it one more time. 187.84 and 202.16. This was situation B. Yes. So this is response B. This was 95%. 95% two-sided confidence interval, yes, if we used known variance, yes, and standard normal distribution quantile. So this was B, and now I will compare this result with different result for a larger sample. Yeah? So this was 95% two-sided interval, and now I will delete this. We are using n equal to 100 batteries. Yes. So 100 batteries instead of 30. Two-sided interval, two-sided confidence interval. There was x with stripe minus z1 minus alpha divided by 2 times sigma divided by square root from n, left side, and right side, x with stripe plus z1 minus alpha divided by 2 times sigma divided by square root from n. Yes, there, in the case of B, yes, we used 195 minus 1.96 times 20 divided by square root from 30, and 195 plus 1.96 times 20 divided by square root from 30. And now I will use 195 minus quantile of the standard normal distribution. We are still using 95% confidence interval. So quantile is the same, yes? 1.96 times sigma 20 divided by square root from 100, yes? Larger sample. And on the right side, 195 plus 1.96 times 20 divided by square root from 100. So you can compare this value with this value. 20 divided by square root from 30 is 3.65. You can see that is 3.65 and there is 3.65. 20 divided by 100. 20 divided by square root from 100. 2, yes, so there is 2, and there is 2, yes, so smaller, lower number, yes, quantile times lower number than before. What it means that the confidence interval, yes, will be tinier than before. So 20 divided by square root from 100 times 1.96, 195 minus this value, 191.08. So this is left side and right side. 20 divided by square root from 100 times 1.96 plus 195. 198.92. So this is 95% two-sided, yes, 95% two-sided confidence interval. If we use random selection, 100 batteries is tinier than before, yes, because we have larger sample, yes, in this situation. Why I didn't use student T quantile? I wanted to illustrate this the situation with known standard deviation, because if I wanted to show you different confidence interval with student T distribution, you know that we need to know degrees of freedom, ni, yes, and ni is n minus 1, 100 minus 1. So we should find student T quantile with 99 degrees of freedom, and there is n 30. Yeah, there's only 30 degrees of freedom. So we should use value that is 2.042. Yeah, the last value 2.042, the column in the middle. But we don't have more degrees of freedom. We should calculate this, for example, in Microsoft Excel, but it's not necessary. Yes, I show to you illustration, the demonstration in the case of known standard deviation. Yes. Okay. Okay. How would the confidence intervals change? Confidence intervals. I will show to you one change, yes, only one. You can calculate the same with the second one, with the second interval at home, yes. So how will the confidence interval change if all the calculations were carried out under a confidence level of 99%? So confidence level. I will clean a whiteboard. I will clean this whiteboard, and you know that we used confidence level 1 minus alpha equal to 0.95. 95% confidence intervals, yes? And now we are using 1 minus alpha equal to 0.99, yes? Okay, so where is the difference? In quantile, yes? Because we know that the formula is x with stripe minus, we will use known standard deviation, known sigma squared, yes? So I will use confidence interval with standardized quantiles. X with stripe minus z 1 minus alpha divided by 2 times sigma divided by square root from n, and on the right side x with stripe plus z 1 minus alpha divided by 2 times sigma divided by square root from n, yes? So this is our confidence interval. I will delete this part from the whiteboard, and I will rewrite this result, which was written here. No, we will compare this with the original result, with original 95% two-sided confidence interval for n equal to 30. Yes, 95% confidence interval, n equal to 30. So original value was 187.84. 187.84 left bound, and right bound, right side, 202.16. 202.16. And now, because we are using 1 minus alpha 0.99, there is 1 minus 0.01 divided by 2. 1/2 from 1% is 1/2 of percent. 100 minus 1/2 of percent is 99.5%, 0.995. So you will check your tables, quantiles of the standard normal distributions at P, and you will find 99.5% quantile 2.576. 2.576. Yes, 2.576. 2.576. Okay, so the mean 195. Yes, 195 days minus this quantile times, and we will use again known standard deviation 20 and original sample size, original sample 30. Yes, divided by square root from 30. So this is left bound and right bound. 195 plus 2.576 times 20 divided by square root from 30. Yes. Okay. So we will solve this and we will compare the result. So 20 divided by square root from 30 times 2.576. Can you see this ratio times larger number than before, larger quantile? Yes, original quantile, if we use 95% confidence level, was 1.96. 1.96, and there is larger value. So there is mean minus larger value than before. 195 minus larger value than before. So left side 185.60 59 days. 59 days. Left side and right side 20 divided by square root from 30 times 2.576. So there is again larger number than before, yes, plus the mean 195, 204.41 days. So this is situation 99% confidence interval n equal to 30. Yes. Can you see the difference? Yes. This confidence interval is wider than before. Yes. So there is a difference. Higher confidence level, 99%, means that we have wider confidence interval than before, yes, because we require, yes, 99% probability that the battery lifetime will be placed inside the confidence interval, yes, inside this interval, at least 185.59 days, and at most, yes, the battery lifetime 204.41 days, yes. You can try to calculate this at home, yes, for example for n equal to 100, yes, and you can try to calculate this using student t quantiles, etc. Yes, you can work, you can practice with this. We will continue another example. 500 products were randomly selected from a large delivery of 10,000 products. Okay, so again, we will denote this large delivery, yes? For example, capital N is equal to 10,000 products. For example, LCD displays, yes? You ordered a lot of LCD displays, 10,000 displays, yes? And from this large delivery, population of displays, LCD displays, yes? We selected, randomly selected, small n equal to 500, yes? You selected 500 boxes with displays. You open these boxes, yes, and you check the quality of these displays, yes, and you found that 378 of them being of a premium quality, so the display is not broken, for example, yes. So we know that small m, yes, special characteristic, the display, LCD display is alright, premium quality is equal to 378, yes? Okay, so we know these statistics. Using 95% two-sided confidence interval, estimate the proportion of premium quality products in all delivery, yes? So we will use confidence interval for the proportion, two-sided confidence interval. We know that the confidence level 1 minus alpha is equal to 0.95. 95% confidence level, yes? We are statisticians, so we are using a relative number. Okay, so we will check out formulas, and we will find formula for population proportion, large sample, two-sided confidence interval for parameter p, large sample, yes? You can see that we have n equal to 500, a large sample, it means at least 30 observations, yes? So in our situation, we have really large sample, so I will rewrite this formula on the left side, P, the proportion of premium quality products in our sample minus quantile Z 1 minus alpha divided by 2, Z 1 minus alpha divided by 2, this is quantile, standard normal distribution, times square root, and there is p times 1 minus p divided by n. So this is the left side, yes, left bound. And right side, proportion plus z. 1 minus alpha divided by 2 times square root p times 1 minus p divided by our sample, our random sample n. So left side, right side. We know that confidence level is 95%, yes, 1 minus alpha. There is quantile 1 minus alpha divided by 2. There is quantile 1 minus alpha divided by 2. We must share our power. Yes? This confidence level must be shared on the left side and right side. So we will find in our statistical tables Z 0.975, 97.5% quantile of the standard normal distribution. And you remember that this value is 1.96. We already used this value, 1.96. And finally, we must calculate the proportion this p-value, this proportion of premium quality products in our sample. Yes, our sample 500 displays. Number of premium quality displays 378. M divided by n is equal to proportion of premium quality products. 378 divided by 500. Yes, 378 divided by 500, 0.756. 0.756. We know that this is possible to interpret in percent. 75.6% of premium quality displays in your sample. Yes, you selected 500 boxes. Yes, you opened these boxes and you found that in your sample is 75.6% unbroken. Yes, displays of premium quality. So we will use this information and we will construct the 95% two-sided confidence interval. So, proportion 0.756 minus 1.96 times square root from 0.756 times 1 minus 0.756 divided by 500 displays. Yeah? So this is left side and right side. 0.756 plus 1.96 times square root, and that is 0.756 times 1 minus 0.756 divided by 500. Okay, so I will delete this middle part from the whiteboard and we will calculate two results, left side and right side. Yes, so what is here? 1 minus 0.756 times 0.756 divided by 500, square root from this value, times 1.96 and 0.756 minus this value, 0.7184. 7184. So this is left side and right side. Again, we must start here inside parentheses. Yes, 1 minus 0.756 times 0.756 divided by 500, square root from this value times 1.96 plus 0.756, 7936. Okay, what was the question? Using a 95% two-sided confidence interval, estimate the proportion of premium quality products in the whole delivery. Proportion of the premium quality products. Proportion. So we can multiply these values by 100 and interpret in percent. 71.84% is the left side, left bound, and 79.36% is the right side. Yes, with confidence level 95%. Yes, you can expect. Yes, you can expect that in all delivery, yes, in all delivery of displays is at least 71.84% premium quality displays, and at most 79.36% of premium quality displays. Yes. So this is proportion, and we can calculate number of displays. Yes, we can calculate number of displays in this delivery. Yes, because you know that n capital N, population, yes, you ordered 10,000 displays, so we can use this value N times this relative number, and this relative number times capital N, 10,000. What it means? 7,184 displays, LCD, liquid crystal displays, LCD, and right side, right bound, 7,936 LCD. Yes, displays. So this is a number, yes, total number of premium quality displays in all delivery. At least 7,184 displays, at most 7,936 displays in all delivery. Yes, this is 95% two-sided confidence interval. Yes. We will construct 95% two-sided confidence interval for the number of, we already calculated, yes, B. We already calculated B, so this is number, yes. We multiplied proportion by the population, number of all displays, yes. So we already calculated B. And again, this is supplement for you, because Mr. Hellman didn't write to your formulas one-sided intervals, but in statistics we also calculate only one-sided intervals, yes? Not every time two-sided, one-sided. So there is our confidence interval for population proportion, and I will delete this part from the whiteboard, and you know that we require construct 95%, yes, 95% one-sided, right-sided, yes, confidence interval. So I must calculate the right side, yes. Right side. So all confidence, yes, will be placed on the right side. Can you see this 1 minus alpha divided by 2 here? Confidence level, this 95% is 1 minus alpha, yes? This is two-sided interval, so I must share this confidence on the left side and on the right side. Now I will use all power on the right side, yes? So left side will be 0, unknown value, yes? And right side will be proportion plus all my power, z 1 minus alpha. All confidence will be placed on the right side, yes? Times square root, and there is P times 1 minus P divided by N. Can you see the difference? This is two-sided confidence interval. You are calculating the left side and right side. This is only one-sided, right side confidence interval. Left side, 0, unknown value, yes. And all power, all my confidence is concentrated on the right side, yes? So I will delete this middle part from the whiteboard. You know that we must find in our statistical tables different quantile, yes, Z 0.95, 95% quantile of standard normal distribution. So this value is 1.645, yes? And we will solve this. So left side is 0 and right side 0.756 plus 1.645 times square root, there is 0.756 times 1 minus 0.756 6. And this is divided by n, our sample size, 500 opened boxes, yes, with displays. Okay, so 1 minus 0.756 times 0.756 divided by 500, square root from this value times 1.645 plus 0.756. I will delete this formula on the bottom, yes, and I will write the result here. So left side is unknown, yes, and the right side 0.7876. 7876. Okay, so this is proportion. The question was, calculate 95% right-sided confidence for proportion of premium quality products in all delivery. So this value means 78.76%, yes? And of course, you can use this value and multiply this value by capital N, population, yes, and interpret like a total number of displays, 7,876 LCD, liquid crystal displays. So this is the total number of displays. Yes? So with 95% probability, you can expect, yes, with 95% probability, you can expect that the total number, yes, the maximum potential number of premium quality displays, yes, in all your delivery is 7,876. So this is maximum potential number which you can expect with 95% probability, 95% confidence level, yes? The lower bound is unknown because we concentrated all power only on the right side, yes? So there is two-sided, yes, two-sided confidence level, and this is only right-sided. This right-sided confidence interval is supplement for you because I say that it's good to know that we are using also one-sided confidence interval, yes, because sometimes it's good to concentrate all power, all confidence only on one side, yes, for example, maximum or minimum. Okay, we will continue. Students wrote a test. We will use the data in the table below and we will determine with 95 and 99% confidence level the intervals of average number of achieved points of students from the midterm test of statistics. So students wrote a test, yes, females and males. So we have here two separated samples, yes, sample of females and sample of males. Nothing else is written here, so we don't know the distribution of achieved points. Yeah? There is not written that we can use normal distribution, there is not written anything. So we must calculate a sample statistics, yes, according to data set. So can you see there is observation, yes, number of observation. If you check this sample, these two samples, you will find that we have here 52 females and 32 males. Yes, so these two samples are different in its size. It doesn't matter, yes, it's alright, but I know that small n1, yes, first sample, randomly selected sample, is equal to 52 values, yes, 52 observations, and the second sample, N2, is equal to 32. So we have here two independent samples, and because N is higher than 30, yes, we can use formula in this formula sheet, general distribution in population. Variance, yes, in these two samples, females and males, is unknown, yes. There's written large sample N higher than 30 observation, it's alright. We have 52 and 32. So, I will rewrite this formula, yes, for two-sided confidence interval for parameter EX, expected value. Because we don't know that there is normal distribution, normally distributed points, yes. We will use general distribution EX, so left side of this interval X with stripe minus quantile of the standard normal distribution Z1 minus alpha divided by 2, Z1 minus alpha divided by 2 times, and there is sample standard deviation. Standard deviation calculated from the sample divided by square root of n. So this is left side, and right side of this interval X with stripe plus Z1 minus alpha divided by 2 times standard deviation divided by square root from n. Okay. So this is a formula. We must calculate two sample statistics, yes? The sample mean for females and for males, and sample standard deviation. The mean is easy, yes? X with stripe is equal to summation through all E, XE divided by n. Yes, this is sample mean. And standard deviation, you have standard deviation written in your formulas. In your formulas, on the second page of your formulas, yes, sample standard deviation. Do you remember classical formula for variance? Variance as x squared, yes. Variance is equal to, there is summation through all E and in parentheses xe minus x with stripe, this is squared, yes, divided by n. This was classical variance, which we used in the descriptive statistics, yes. Standard deviation as x, so without square, is square root. Yes, square root. And in the case of samples, we are using a little bit smaller denominator, n minus 1. N minus 1 in denominator. So, for the first time, yes, we will calculate our own standard deviation. Zoom. Standard deviation calculated from the sample, yes, from the sample, this one, yes, S, square root from S squared, square root from sample variance. Variance is every time unknown in these examples, yes, because we have two independent samples, N1 and N2 females and males. So we will calculate two means, two averages. Yes? So we can use classical function equal sign average. Yes, equal sign average, and you can select 52 values. Yes, and average with 3 decimals. Average with 3 decimals is 16.058. So this is average, this is the mean for females. So x1 x1 with stripe, yes? So this is average for females is equal to 16.058 and the same, yes? Equal sign average and average from 32 values, yes? 32 values of males, yes, equal sign average. 15.719, 15.719. So this will be x2 with stripe equal to 15.719. You can see that females, yes, have a little bit higher sample mean, yes. Sample mean. What is this sample mean? You can check your formulas, yes, and you can find the first row on the page with intervals of confidence. Calculated point, population, population parameter estimates. General distribution in population. Large sample when n is higher than 30, estimated expected value EX is equal to x with stripe, the mean. We calculated, yes, now we calculated 2 point estimates, yes, 2 point estimates for expected value, yes. For expected value, expected number of points achieved by females, yes, and expected number of points achieved by males, yes. So there we have 2 point estimates, yes. Okay, but we would like to determine interval. Confidence intervals, yes, interval estimates. So we'll continue, yes, we will continue with sample standard deviation, yes. So we will use this formula, yes, S, sample standard deviation. So we will calculate 52 squared differences, 52 squared differences for females, and 32 squared differences for males, yes? So, we can start equal sign, we will open the parenthesis, number, yes, of achieved points, the value, minus mean for females. We will use function 4, yes, F4, function 4 button, because we must log the cell of the mean of point estimate, yes, of this expected value, and this will be squared, yes. You can use left out 94, yes, combination 94, and you will see the hat, yes, the power function. So it's squared. And there as well, yes, this value, in parentheses, this value minus the mean, yes, the mean, function 4. We will lock the cell, and again, parenthesis, with hat, yes, and square, yes, this hat, left out, 94, and you will see this function, squared. So we have 52 and 32, 52 and 32 square differences. So we will calculate summation, yes, summation, and we will receive 2 nominators. So sum of these square differences for females, 735 point something, and sum of 32 squared differences for males, 322 point something. Okay, so I will rewrite. Summation of square differences for females and males will be divided. So will be divided by n minus 1. So S standard deviation is equal to, I will write denominator, 735.327 divided by 52 minus 1. This will be first standard deviation, and second standard deviation will be equal to, no, there must be, sorry, square root, yes, and there must be also square root, yes. So the second one, 322.969 divided by 32 minus 1. Yes? So first standard deviation, second standard deviation. S1 is equal. So there is SQRT equal sign SQRT square root. Nominator divided by 51. Final standard deviation is 3.797. Yes. 3.797. So result is in points. Yes, because this is standard deviation, result is in points, in basic units. And second standard deviation, S2, is equal to SQRT square root from denominator divided by 31. 3.228. 3.228. Okay, so we have two means, yes, two calculated averages, two point estimates, yes, point estimates. We have sample standard deviation because the variance Vx, yes, variance Vx samples is unknown. We calculated our own two standard deviations. Now we can use this formula, this general formula, and construct 95 and 99% confidence intervals, yes, for females and for males, for expected number of achieved points from the midterm test. So you calculated manually, yes, you calculated manually sample standard deviation, but during our seminars we have available Microsoft Excel. So you know how can you calculate the sample mean, equal sign, average, yes? And we can calculate fastly sample standard deviation in Microsoft Excel. So you can use this function equal sign stdev, standard deviation stdev dot sample dot s, yes, stdev dot s dot sample estimates the sample standard deviation from the data set, yes? So please write here stdev.s equal sign stdev.s calculates .s, please, s estimates standard deviation based on a sample, yes? So we have here a sample, so this function will estimate standard deviation from the sample, yes? So you will select the data, you will close the parenthesis, yes? You will press enter button and you can see that there is the same result, yeah? The same results for females and for males. So we will use this data, and we will construct confidence intervals. So I will rewrite these partial values here on the left side. So S1 is equal to 3.797 and S2 is equal to 3.228. 228. So 95 and 99% confidence level. So what it means? 1 minus alpha is my confidence level, yes? And this must be equal to 0.95 and 0.95 and 99% confidence level. So you can see we are using quantiles. We are using quantiles of the standard normal distribution. So, because this is two-sided, yes, interval, there is alpha divided by 2. We must share this alpha. So, in the first case, 95%, we will use quantile Z, 1 minus 0.05 divided by 2. In the case of, in the second case, we will use Z, 1 minus 0.01 divided by 2. So there will be Z 0.975 and there will be Z 0.995. Okay, Z 0.975 will be written here, and the Z 0.995 will be written here. Yes, so we will check our tables. Yes, the table for quantiles of the standard normal distribution ZP, p-value 0.975. You know, yes, 1.96. So there is 1.96. So this will be first quantile. Yes, first important quantile for us. And 99.5% quantile. So we will scroll down, and there is p-value 0.995, 2.576, 2.576. Okay, so now we know everything. Yes. So we will start with 95% confidence intervals, yes, for females, and for males. So we can use the values. So the mean for females, 16.058 minus 97.5% quantile, 1.96 times standard deviation for females, 3.797 divided by square root from n. There is n, not n minus 1. Yes, so 52, square root from 52. This is left side. Right side, 16.058 plus 1.96 times standard deviation, sample standard deviation for females, 3.797 divided by square root from 52 values. Yes, so we can calculate this. 3.797 divided by square root from 52. times 1.96 and 16.058 minus this value. So left side 15.026. 15.026. Yeah, this is left side. And right side 3.797 divided by square root from 52 times 1.96 plus 16.058. 17.090. Okay, so this is 95% confidence interval for females. We'll continue with males. Yes, so males will be here. Okay, left side 15.719 minus again 97.5% quantile 1.96 times standard deviation for males 3.228 divided by square root from n. We know that we have 32 males. 32. So this is the left side. And right side, again, the mean. 15.719 plus 1.96 times standard deviation, sample standard deviation for males. 3.228 divided by square root from 32 males. Yes, 32. Okay, so we can solve this. 3.228 divided by square root from 32 times 1.96, 15.719 minus this value 14.601. 14.600. Yeah, so this is the left side. Okay, we will continue with the right side. Yes, so 3.228 divided by square root from 32 times 1.96 plus 15.719. So right side 16.837. Okay, so we have here 95% confidence interval for females and for males for expected number. Yes, expected number of achieved points. Yes, females and males. Okay, we will continue with 99% confidence intervals. From the whiteboard, I deleted the results, yes, and you can see that only one difference, yes, only one difference. If you want to change the confidence level, yes, is quantile. Only one change. So Z1 minus alpha divided by 2 will be now, instead of value 1.96, value 2.576. So there is confidence level as confidence interval for females. I will delete this value minus 1.96, and here I will delete this value plus 1.96, and here also I will delete this value minus 1.96 and this value plus 1.96, and we will write here minus 2.576. 2.576, yes, and here I will write plus 2.576, yes, and here I will write minus 2.576, yes, and here I will write plus 2.576, yes, and we will recalculate the results, yes, for females and for males. So 3.797 divided by square root from 52 times times 2.576. 2.576, and now 16.058 minus this value, so left side 14.702, 702, so this is the left side of 99% confidence interval. Right side 3.797 divided by square root from 52 times this quantile 2.576, and now plus 16.058. So right side 414. Okay, so left side 14.702, right side 17.414. So this is 99% confidence interval for expected value, expected number of achieved points for females, yes, and the same for males. So left side 3.228 divided by square root from 32 boys times this quantile 2.576, 15.719 minus this value, left side 14.249, 14.249, yes, this is the left side, left bound, and right side, right bound for expected number of achieved points, 3.228 divided by square root from 32 times 2.576 plus 15.719, 189. Okay, so we have here two 99% confidence intervals for expected number, expected value, yes, expected number of achieved points from the midterm test. Females 95%, females 99%, because the quantile for 99% confidence level, yes, is higher, yes. You can see, recognize that this value in this case is a little bit higher. Standard deviation divided by something times higher value, and there is point estimate of expected value, yes, the mean, average, minus higher value than before. There is point estimate, average, plus higher value than before. So you can see that in case of 99% confidence, the confidence interval is higher, is larger, yes. confidence interval is tinier. Yes, if you are using less confidence. The same for males. Yes, 95% confidence level, 14.6, 16.8. Yes, in the case of 99%, 14.2, 17.2. Yes, the confidence interval is tinier. Yes, if you are using less confidence, and must be wider as than before. We are using higher confidence. Yes, because in the first case you would like to be sure in 95% of all cases. Yes, that the expected value, expected number of achieved points will be placed. Yes, will be placed inside this interval, and there you require, to be in 99% sure, yes, that expected value, yes, the mean expected value will be placed inside this interval. Yes, so remember this. This was the case. This was the case of general distribution. Yes, we don't know if the distribution of points is normally distributed or not. So we use the general formula. Yes, all assumptions, yes, were fulfilled because we had two large samples. Yes, females and males. Higher, more than 30 observation. Yes, so that's all. Okay, so this is the end. This is the end of the 9th seminar of our academic semester, confidence intervals. Yes. This seminar is a little bit shorter, but I show to you everything what is necessary for 9th seminar, more than everything, because I show to you also one-sided confidence intervals, which are not in your formulas. Yes, in your formulas you have only two-sided intervals, but I show to you also the situation where the power, all confidence is concentrated on one side, either left side or right side. Yes, so I show to you more. So study at home, practice at home. This is the end of the 9th seminar. I hope that I will see you next week in 10th seminar for our academic semester. So thank you for your attention, and bye bye.